guys, welcome back. So in this video I'll be going over linear functions and graph. So this plane right here is called the Cartesian plane. Let me just write that. So this is a Cartesian plane, right? So as you can see, this plane has two axes, x-axis and y-axis. This is the x-axis and this is the y-axis, and these axes intersect at 90 degree, right? They're meeting at 90 degree to each other. Now let me just erase this thing. Okay, so you can number these graphs or these axes according to your own need. So basically you scale them. So let's say my scale for x-axis is 2 centimeter to represent 1 unit, right? So by that I mean that each block will differ by 2 centimeters. So our first block, okay, so for now you must remember that the origin is the point where these two axes intersect, right? So this for now must be 0. Okay, so when I say 2 centimeters represent 1 unit, each line represent 1 unit. So this is 1 unit, this is the second, this is the third, this is the fourth, this is the fifth, and so on, right? Now if each unit is representing 2 centimeters, then when 1 unit increases, we increase by 2 centimeters. So from 0 plus 2 will be 2, and 2 plus 2 is 4, 4 plus 2 is 6, then 8, then 10, then 12, then 14. So in the same way, you can allot any scale you want. So 2 centimeters can represent 1 unit, 4 centimeters can represent 1 unit. It doesn't necessarily have to be an even number. So even 3 centimeters can represent 1 unit, right? As long as it follows a pattern, like each number is differing by 1, so the difference must be equal, right? As long as that's true, your scale is good to go, right? So let's say that 3 centimeters represent 1 unit on the y-axis. So our first unit will be 3, then 6, then 9, then 12, and then 15, and so on, right? Now if I plot a point over here, so over here, right? Now this point, for this point, the x-coordinate will be where it lies. So the x-coordinate is 10, right? And the y-coordinate will be this line. So it will be 12. So this point lies on 10, 12. That means the x-coordinate of this point is 10 and the y-coordinate is 12. Now let's say the examiner says, tells you to plot a point on 9, 15, right? So 9 must lie somewhere between 8 and 10. So it will lie halfway through over here, and then 15. So 15 is on this line, right? On this line. So our point will lie somewhere over here, and we can label this as 9, 15. 0, 0 is this point, origin, because on this point, x-coordinate is also 0 and y-coordinate is also 0, right? The origin is always 0, 0. It's where the x and the y axes intersect. Okay, now let's learn about a linear function. So a linear function is basically the relationship between two variables. So if I write something like y is equal to x, so this function has two variables, right? And an equals to sign. So this is a function. And what exactly is a function? A function is a relationship between variables. And because it's a linear function, then it includes two variables. So linear function, so two relationship between two variables, right? So let's see. So this function can be y is equals to 2x, y is equal to x over 4, y is equal to 2x plus 4, y is equals to 3x minus 6. So it can be anything. As long as it includes two variables, it can be a linear function, right? So what basically happens is you input a value. So let's say you are inputting the value of x. So let's take this function first. Y is equal to 2x, right? Now your input for this function is x is equal to 2. Now what you do is you basically put this in this. So y is equal to 2 and our input was 2. So in place of x we write 2 and y is equal to 4. So this is our input while this is our output, right? We can do the same thing for this. So y is equals to 3x minus 6 is our function. Our input value is, again, let's say 6, right? 2. So our input is 2. So what we basically do is we basically put 2 in place of x and then minus 6. So 3 into 2 is 6, 6 minus 6, and 6 minus 6 is 0. So our output value will be 0, right? But we have already learned all this in the previous video. Now let's look at graphs of linear functions, right? So graphs of linear functions. Okay, so let's say we have a function y is equal to 2x, right? So what we basically do is we suppose values for x. So we make a table, something like this. So here we have our x values and here we have our y values. So we assume a few values for x. So let's say we assume minus 3, minus 2, minus 1, 0, 1, 2, and 3. These values are more than enough. Now what we do is we basically put each value in this function to obtain the output value, the value of y. So let's put first minus 3 into this function. So minus 3 times 2 is minus 6. So our output value will be minus 6. Now minus 2 times 2 is minus 4. Minus 1 times 2 is minus 2. 0 times 2 is 0. So I'm basically just putting every x value in this function. 1 times 2 is 2. 2 times 2 is 4. And 2 times 3 is 6. So now we number the x's. So we have 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5. And here we have 2, 4, 6, 8, minus 2, minus 4, minus 6, and minus 8, right? So on the x-axis, my scale is 1 unit for 1 centimeter, because after every block we are differing by only 1 centimeter. So my scale for x-axis is 1 unit represents 1 centimeter, and for y-axis it's that, sorry, it's axis, it's that 1 unit represents 2 centimeter, right? Because after every unit we are differing by 2 centimeters. So let's just now plot the points. So on minus 3, when the x value is minus 3, our y value is minus 6. So minus 3 is here and minus 6 is somewhere over here. So this is minus 3 comma minus 6, our first point. Then we have minus 2 comma minus 4. This is minus 2, this is minus 4, so this. Then we have minus 1 comma minus 2, which is this. 0 comma 0, this. 2 1 comma 2, so 1 2, 2 comma 4, x coordinate 2, y coordinate 4, and 3 comma 6, x coordinate 3 and y coordinate 6. So we're here. So we have basically a straight line. So we have a straight line over here. Let's just draw a line. Okay, so this is my line. Now I can exceed the line by both ends. So this, and let's draw an additional line. Okay, so I've drawn the line, and this is what basically a linear graph looks like. A linear graph is always, we always get a line in linear graphs. So this a line like this, or a straight line a little bit lower of that, so something like this. So basically we will always get a line whenever we draw a linear graph. We can also get a straight horizontal line and a vertical one too. So it doesn't really matter, like the line does not have to be slant. We can get a straight line, a vertical line, and we can also get a line which is not passing from the origin, right? So we can get a vertical line too. For this graph, our line is this one, right? That's it for this video. I hope you all learned something. Goodbye.